Hi there, Mr. Sutton here with the Pre-Cal Honors 2-2 Extra Practice Number 2 solutions on synthetic division. For this problem, to find the remainder and all the other information, I'm going to use synthetic division to perform this division. So we start by writing down our coefficients for the polynomial. We're starting with a 1x to the fourth, so 1 is our first coefficient. And we're missing an x cubed, so that's kind of tricky. That means we have a placeholder 0 to represent the 0 x cubed that we didn't bother writing. Now we have a negative 15 for the x squared, a positive 10 for the x, and negative 40 to represent that constant. We have a box number of 5 because that zeroes out our divisor of x minus 5. We leave some space, write a line, and then we'll start by bringing down that first coefficient of 1. So I'm multiplying my box number by all these bottom row numbers. 5 times 1 gives me 5, and I put that in the second row. Now we add the top two rows. So 0 plus 5 is 5, and now we just repeat the process. 5 times 5 is 25. Negative 15 plus 25 is 10. 5 times 10 is 50. 10 plus 50 is 60. And then finally, 5 times 60 gives us 300. Negative 40 plus that is going to give us 260. That last number is our remainder of 260. Since that's not 0, that means x minus 5 is not a factor of our polynomial. And for the quotient, that's going to be all the numbers except for the remainder. So 1 is going to represent 1x to the third, because it's one exponent lower than you started with, because you did x to the fourth divided by x. And next we have a 5x squared plus 10x plus 60. For this problem, we want to find the remainder by dividing this massive polynomial by x plus 1, and also if x plus 1 is a factor and the quotient from all this. So we're going to use synthetic division to make this happen since we need all of this information. We'll start by writing down the coefficients of this big polynomial. We start with a 3 for the 3x to the 7th. And let's see, we've got a minus 5 is the next one, and a negative 4. We have a 2, and I'm checking for placeholder zeros as I go, but it doesn't look like I'm missing any terms here. So after the 2, we have a 3, followed by, this is 1x squared, minus 4, and then minus 1 for that constant. Since x plus 1 is our divisor, our box number is going to be negative 1, because that zeroes out the divisor. Leave some space, draw a line, and bring down your first coefficient, which was 3. So I'm going to multiply this negative 1 box number times all these bottom row numbers. We have negative 1 times 3, giving me negative 3. Now I add these top two rows to get the rest of the bottom row numbers. So negative 5 and negative 3 adds up to negative 8. Times negative 1 gives us a positive 8 here. Negative 4 plus 8 is 4. Times negative 1 is a negative 4 up here. 2 plus negative 4 is negative 2. Negative 2 times the negative 1 is positive 2. 3 plus 2 is 5. Times negative 1 is negative 5. Plus 1 is going to be negative 4. Times negative 1 is 4. And then we add that with a negative 4 to get 0 down here. Negative 1 times this 0 gives us a 0 up here. And negative 1 plus 0 is still negative 1. So that last number, that last negative 1, that is our remainder of negative 1. Since that's not 0, it means that after all that work, x plus 1 is not actually a factor of the polynomial. For the quotient, that's going to be all these numbers except for that remainder of negative 1. So we have a 3 for our first coefficient on the quotient. That's going to be 3x to the one exponent lower than we started with, so 3x to the 6. And then we have minus 8x to the 5th, plus 4x to the 4th, minus 2 x cubed plus 5x squared minus 4x. And you don't need to write a plus 0, but that 0 does represent the constant that you don't see in the quotient. To solve this problem, we're going to use the process of synthetic division. So we'll start by writing down our coefficients. For the x cubed, that's a coefficient of 1. And then we have a 3, negative 5 for the x term, and then a negative 4. We'll have a box number of negative 4 because that zeroes out our divisor of x plus 4. And then we have a space and a line. All right, so let's go through some number crunching. Bring down our first coefficient of 1. And now negative 4 gets multiplied by all the bottom row numbers. So negative 4 times 1 is negative 4. The top two rows now get added together. So 3 plus negative 4 is negative 1. Negative 4 times negative 1 gives us a 4 up there. Negative 5 plus 4 is negative 1 again. Negative 4 times negative 1 again is 4. And then negative 4 plus 4 gives us 0. Since we have a remainder of 0, that last number there is our remainder. That means that x plus 4 is a factor of our polynomial, so yes to that question. For the quotient, that's going to be all these numbers here except the remainder. So all these bottom row numbers are our coefficients. This 1 really represents 1x to the second because it's one exponent lower than we started with. So 1x squared minus x, and then this minus 1 here represents just minus 1. For this problem, trying to figure out the remainder, whether the divisor is a factor, and the quotient, we'll use synthetic division to answer all these questions. So let's start by writing down the coefficients of our polynomial. We start with the 5 for the 5x cubed, and we're following that up with the 0 for the 0x squared that we're not writing, so we need a placeholder 0. Then we have a negative 55 for the linear term, and a negative 20 for the constant. Our box number is going to be negative 4 because that zeroes out x plus 4. And now we have some space and a line. Bringing down our first coefficient, we have a 5 down here. And now our box number of negative 4 gets multiplied by all these bottom row numbers. So negative 4 times 5 is negative 20. That goes in the second row. We add the top two rows to get the rest of the bottom row numbers. So 0 plus negative 20 is negative 20. Negative 4 times negative 20 is 80. Negative 55 plus 80 is going to be positive 25. Negative 4 times 25 is negative 100. Negative 20 plus negative 100 is negative 120. That last number is our remainder of negative 120. Since that's not 0, that means x plus 4 is not a factor of the polynomial we divided it by. And for our quotient, that's all the numbers down in the bottom row except for the remainder. And we're going to start one exponent lower than we started. X cubed divided by an x gives us an x squared. So this 5 represents 5x squared. And then we have a minus 20x, and finally a plus 25. For this problem, to find the remainder and all the rest of it, we're going to use synthetic division. So we start with the coefficients of our polynomial. So we have a 1 to start with because we have a 1x cubed there. And now we have a 3 for the x squared, a 10 for the x, and a negative 14 is our last coefficient. Our box number is going to be negative 1 because that zeroes out our divisor of x plus 1, so negative 1 box number. Leave some space, draw a line, and now bring down your first coefficient of 1. At this point, negative 1, the box number gets multiplied by all these bottom row numbers. Negative 1 times 1 gives us a negative 1 in the second row. Adding the top two rows now, we have 3 plus negative 1 to get 2, and then negative 1 times 2 is negative 2. 10 plus negative 2 is 8. Negative 1 times 8 is negative 8. And negative 14 plus negative 8 is negative 22. That last number is our remainder of negative 22. Since that's not 0, that means x plus 1 is not a factor of the polynomial. For the quotient, that's all the numbers in the bottom except for the remainder. So we have a 1x to the second power because our remainder is going to be, our quotient rather, is going to be one exponent lower than what we started with. We divided an x cubed by an x to get an x squared down here. And after that we have a 2x, and then this 8 really means plus 8. For this problem, we're going to use synthetic division to answer all these questions. So let's start with the coefficients of our polynomial. We have a 4, a negative 18, a positive 9, and a negative 13. No placeholder zeros because we didn't skip any terms. Since x minus 3 is our divisor, our box number is going to be whatever zeroes that out, so positive 3. Leave some space, draw a line, and now let's bring down our first coefficient below the line. So that 4 goes down there, and we're going to multiply our box number 3 times all the bottom row numbers and put them in the second row. 3 times 4 gives us a 12 up there. Now we add the top two rows to get the rest of the bottom row. So negative 18 plus 12 is negative 6. 3 times negative 6 is negative 18. 9 plus negative 18 is negative 9. 3 times negative 9 is negative 27. And negative 13 plus negative 27 is negative 40. That last number is our remainder of negative 40. Since that's not 0, that means x minus 3 is not a factor of our polynomial. For the quotient, we're going to use the bottom row numbers except for the remainder. And our exponent's going to be 1 lower than we started. So this 4 down here represents a 4x squared because we had an x cubed divided by an x, so that's x squared. And now we have a minus 6x minus 9. For this problem, we're trying to find the remainder and whether x plus 1's a factor of this original quadratic here, along with the quotient. So we'll use synthetic division for this. It's probably the fastest way. So let me write down my coefficients for this quadratic. We have a 1x squared to begin, so that's a 1. Minus 4 is the next one, and then we have a minus 5. No placeholder zeros needed here because we didn't skip any terms. For the box number, that's whatever zeroes out my divisor of x plus 1, so that's negative 1 for the box number. Leaving a space and drawing a line, we bring down our first coefficient of 1, and we multiply all these bottom row numbers by our box number. So negative 1 times 1 is negative 1. That goes in the second row. Now we add the top 2 rows to get the bottom row again. Negative 4 plus negative 1 is negative 5. Negative 1 times negative 5 is 5. And negative 5 plus 5 is 0. That last number there is our remainder of 0. Since the remainder is 0, that means that x plus 1 is a factor of the quadratic that we started with. And our quotient is going to be the other numbers down in the bottom row except for the remainder. So this 1 really represents 1x, because when you divide an x squared by an x, you get something that starts with an x. So 1x, and then we also have a minus 5 to go with that. To answer this question, we're going to use synthetic division to get the remainder, whether it's a factor or not, and the quotient. So we'll start with the coefficients for our polynomial. That means 2 is the first thing I write down, followed by, well, there's no x to the fourth. We skipped a term. So I need a 0 placeholder to represent the 0 x to the fourth that we're not writing here. Next, I have a 4 for the x cubed. This is really minus 1 for that coefficient on x squared. Minus 3 for the minus 3x, and then that constant gives us negative 2. For the box number, we've got negative 1 because that zeroes out x plus 1 over there. Leave some space, draw a line, bring down our first coefficient of 2, and our box number gets multiplied by all the bottom row numbers. So we've got negative 1 times 2, giving me a negative 2 in the second row. Add the top 2 rows to get the bottom row. 0 plus negative 2 is negative 2. Times negative 1 gives us positive 2. 4 plus 2 is 6. Negative 1 times 6 is negative 6. Negative 1 and negative 6 adds up to negative 7. Negative 1 times negative 7 is 7. Negative 3 plus 7 is 4. And negative 1 times 4 gives us negative 4. Add that with negative 2 and we get negative 6. That last number down there is our remainder, negative 6. And since that's not 0, that means x plus 1 is not a factor of the polynomial. For the quotient, we use all the other numbers down here except for that last number, which was the remainder. So that means we have a 2x to the, well, let's see here. We started with 2x to the 5th. We divided an x to the 5th by an x. So now we're down to x to the 4th, 2x to the 4th, first term of our quotient, followed by negative 2x cubed plus 6x squared. This is a minus 7x right there, and a plus 4 for the constant.